Hey all you cool sabers, today we're going to take a look at some angle relationships in triangles. So, right off the bat we need some definitions done. So, the vertex is a point where two or more lines meet. Technically I suppose they're line segments, but we'll call them lines and you know what I mean. An interior angle is an angle formed on the points of a polygon, meeting at a vertex. Or maybe it should have been a vertex meeting at a point. That actually probably would have made more sense. Whatever. Same thing. You get it. Formed on, yeah, I don't know. Well, whatever. I probably should restart this and get that right, but I'm not going to. I just don't feel like it. Anyway, the sum of the interior angles of a triangle is, of course, 180 degrees. So let's talk about the isosceles triangle theorem. Everybody knows, I shouldn't say everybody knows, hopefully everybody knows at this point, and if you do, you're about to learn, that an isosceles triangle has two equal sides. But what some people sometimes overlook is that two of the angles in an isosceles triangle are also equal. So we've got this guy right here, triangle ABC, and it tells us that the angle at A here is 40 degrees. So because we know that all the angles add up to 180 degrees, we know that one of those angles is 40, so we know that the other two angles have to equal 140 degrees. Now, because, whoops, that's a 4, because those two angles are exactly the same, we can just divide that by 2, and we get that these are both 70-degree angles. All right? Let's take a look at equilateral triangle theorem. This one, yeah, well, anyway. And that's just that the angles on an equilateral triangle are also equal. And the fun thing about this one is that what they equal is always 60 degrees, because those three angles have to add up to 180 degrees regardless of the size. So all of those angles equal 60 degrees for every equilateral triangle. Equilateral, of course, meaning that all three sides are equal. Let's see. Exterior angle. So, angles formed on the outside of a... I guess I did do it right. Of a point. No, I don't know what that's supposed to be. Of a shape. This is poorly written. I didn't make this handout. I'm going to be honest. I don't really like it. I don't understand what it's supposed to say here. Angles, it's the angle, an exterior angle is just the angle formed on the outside of a... I have no idea. No idea. It's this guy right here. That's what it is. That's your exterior angle. It's that. That. If that's not a good enough description, I don't know what is. But we do have to extend one of the sides past the vertex. So that's where you get this part of the line right here. All right? On the outside of an angle? No, it doesn't make any sense. A vertex shape, of a regular shape, of a 2D shape. It's a 2D shape. Nailed it. Okay. Anyway, at any given vertex, the sum of the exterior... Hold on, let me zoom in here. Exterior and interior angles is 180 degrees. So if I take this angle here that I already drew, and I take that angle there, and I add them together, it will always equal 180 degrees. And that's just because it makes this straight line right there. So that one will seem obvious to some of you. Whatever. If it doesn't seem obvious, don't worry about it, because I just told you. Exterior angles are equal to the sum of the two opposite interior angles. All right. What do I mean by that? What I mean by that is that if I take... So this guy here, it tells us that angle BAC, which is this angle here, is 40 degrees. And then angle ACD is 110 degrees. And what it's saying is that this 110 degrees right here is going to be equal to this one plus this one. All right? So if we do 110 minus 40, which gives us 70 degrees, that will give us this guy right here. Okay, so 40 plus 70 is equal to 110. All right. All right. Sum of the exterior angles in a triangle is equal to 360 degrees. Okay, what's interesting, well, I won't spoil it, but in one of the next lessons we'll learn that that's just always true for every shape. It doesn't matter if it's a triangle or not. So the point is that this angle, this angle, this angle, those three will all add up to 360 degrees. All right, so we just say to find AB, so it's this one here we're looking for right there. So we'll just say 360 minus 130 minus 138. Okay, so let's see, so what is that? I wrote a 6 there, that's what's throwing me off. All right, so we're going to subtract 268, that'll bring us 192. Hopefully I did that right. I did that in my head. If I did it wrong, good job catching me. All right, and that's basically it. The next page, we're going to try all these out, but what I'm going to do is I want you to actually give these a whirl. Some of them are challenging, some of them are easy, but some of them are quite challenging. So give it a whirl, and I will post all the answers. So until next time, go Sabres!